So module 7.5 takes a more general approach in food consumption. So we talked about in earlier modules the process of photosynthesis, whereby you use the energy from the sun, use the CO2, we use water, plants to give us glucose and oxygen. And the fact that we use up energy, we call this an endothermic process. And the reverse process is respiration, where we exhale CO2, we give off water, and we use up energy from our glucose. And this is a exothermic reaction where we release energy in this reaction. And you can see here the energy. You need energy. So this is a graph of energy. You need energy for this reaction to occur, to go to a higher level of energy. And you release energy in respiration, whereby producing CO2 and H2O. So in food, the fat, it contains about 9 calories per gram. Carbohydrates and proteins is 4 calories per gram. So there's less energy is released from carbohydrates. We also saw this when we were talking about oil in refineries, how you can separate out based on the number of carbons that are attached in the oils. And what we want to just discuss here is to show that the consumption of meat is increasing. As you can see here, the amount per person per year takes in about 25 back in the 60s, and they project it to be as high as in the mid 40s by 2030. So we're becoming more of a carnivore civilization over time. And we need to be cognizant of this moving forward to be able. So we have to be cognizant of the costs for this food production. We need water, obviously, for these animals to grow. We need land. Also, when you grow food, there could be pollution as well. So things that we're trying to show here, as we just said, that the land and grain estimates for food production, it takes up a lot of land to grow cows and pork. And I guess that corresponds to the amount of production, with pork and beef being the largest in terms of mass. So as shown, they project that the consumption of meat will increase up to 2030. And on the right side, they're just showing here where in the world this meat is being produced and what type of meat. And according to the data, they estimate if the world population is 8 billion people, this would require 2.9 trillion grain to feed our livestock, which is enormous. So there's a big push to eat locally, food that's grown close to you. And there are many benefits, of course. Economically, it's better. Food is fresher and more nutritious. I don't know if you noticed, but the taste is usually better when you eat locally. There's less transport in the food. As I just said, it supports the economy. It strengthens community ties as well. And it also preserves green space. And what we'll talk about later, we'll talk about it's better for sustainability practices. It reduces our carbon footprint as well. So here's a statistics of the carbon footprint for food production. If you remember, carbon footprint is how much greenhouse gases or CO2 is released due to human activity. So essentially the bulk of it is the production at the farm, the processing, refrigeration, also produces the CO2, transporting, packaging, those all contribute to our carbon footprint. So not just a simple task of growing and eating directly. And you can see here the amount of CO2 produced is the most for steak. Whether you have to feed them, give animals land, water consumption, things of that nature. Versus vegetables, much less. We also have the nitrogen cycle, which is a pathway where N2 from the atmosphere, you guys know it's about 60 to 70% in the atmosphere. We can convert this to ammonia, which is important for plant growth, and this is done through bacteria. You can also have nitrates, remember NO3 minus, through the process of nitrification. So here's a cycle whereby, again, the N2 can get converted to NH3 through the bacteria. And this is not the only process whereby N2 can convert it to NH3, NH4 plus ammonium as well. So we have bacteria that can convert N2 to NH3 and other forms of nitrogen, but we need more. So we use fertilizers. And this came about with the process of a Haber-Bosch process. This is an industrial process whereby we have N2, again, usually the main source is from the atmosphere, plus H2 to give us ammonia. And this occurs at high pressure. Let me balance the equation for you. 2 here and 3 here. As you can see, as the world population increases, the need for nitrogen increases as well. Hence, we have this Haber-Bosch process to help compensate that, or to supplement that from the bacteria. So food security, a very important topic for us. It really comes down to 3 things for food: being available, having the appropriate amount of nutrients in the food, being able to access this, so avoiding food deserts, being able to be close by to this food, and having the knowledge of what is good for you, what is bad for you in terms of nutrition. And this also takes into account water and clean food. So the 3 points are availability, stability, utilization, all connected to access. One thing we talked about was undernourishment, not having enough nutrients for an active lifestyle. And luckily, the data has shown that this number has gone down significantly over the last 25 years. So kudos to that. So we'll end on that note for our module 7.